Have you ever wondered why ice cubes float in your drink? It seems simple, right? You drop them in, and they bob to the top. But have you ever stopped to think about why that happens? What makes ice so special that it defies gravity and floats on water? But this floating ice holds a fascinating secret about water. It's all about density. Density is a measure of how much mass is packed into a given volume. When water freezes, it expands and becomes less dense than its liquid form. We know that stuff either sinks or floats. Rocks sink because they are denser than water. When you drop a rock into a pond, it displaces the water and sinks to the bottom. Beach balls float because they are filled with air, which is much less dense than water. But why does ice, which is solid water, float on liquid water? It all comes down to how tightly packed together the tiny particles are that make up an object. In ice, the water molecules form a crystalline structure that is less dense than liquid water, allowing it to float. Water is special. It's one of the few substances on Earth that behaves in such a unique way when it changes states. When it freezes and becomes ice, something fascinating happens. Unlike most substances, it actually gets less dense. This is why ice floats on water. Picture a group of people dancing wildly at a party. They're moving around, bumping into each other with lots of energy. That's liquid water. The molecules are constantly in motion, colliding and jostling each other. Now imagine the music stops, and everyone stands still in an organized pattern. They arrange themselves neatly, taking up more space. They take up more space this way. That's ice. The molecules form a crystalline structure. The molecules are farther apart, which is why ice is less dense than liquid water. This unique property of water is crucial for life on Earth. Density is how much stuff is packed into a certain space. It's a measure of how tightly matter is crammed together. When we talk about density, we often think about how heavy something feels for its size. Imagine a box full of feathers and another full of rocks. Even if both boxes are the same size, the one with rocks will be much heavier. This is because rocks are denser than feathers. Which is denser? The rocks, of course. Density determines how much mass is in a given volume. Rocks have more mass packed into the same space compared to feathers. Objects less dense than a liquid will float. Remember the dancing people? Just like them, objects that are less dense than the liquid they are in will stay on the surface. Ice is like the people standing still. It takes up more space, making it less dense than water, so it floats. This is why ice cubes float in your drink. The molecules in ice are spread out more than in liquid water, making it less dense. Imagine if ice sank. Lakes and oceans would freeze from the bottom up. Fish and other marine life would lose their homes. The Earth's climate would drastically change. Luckily, ice floats, creating a protective layer for aquatic life and regulating our planet's temperature. So next time you enjoy a cold drink, remember the amazing science behind those floating ice cubes. Speaking of ice, let's turn our attention to the biggest ice blocks on the planet, the massive frozen landscapes of the North and South Poles. Ice in the North and South Poles plays a crucial role in regulating the Earth's climate. The ice caps reflect sunlight, helping to keep our planet cool. In the Arctic, the ice provides a habitat for polar bears, seals, and other wildlife. In Antarctica, the ice sheet holds about 60% of the world's fresh water. If this ice were to melt, it would lead to a significant rise in sea levels, affecting coastal communities worldwide. The presence of ice in these regions is vital for maintaining the balance of our global ecosystem. Thanks for watching! Don't forget to subscribe, like, and share.